All right, so today we've got a HVAC. I'm not really sure how that is pronounced. It's made in the USA, so I don't know. You would think it would be easier to pronounce. But this is a compressor out of a residential HVAC unit, probably 30 years old, something like that. So what this does, this is the pump for, I think we've had an automotive compressor apart before. This is a residential one. I've never actually had one of these apart. I've never seen the inside of one. So it'll be interesting to see what exactly is going on here. This is probably the pressure line coming out. This line over here is probably the input line, and this line here is going to be, I don't know what that's for. Maybe for adding oil. So it looks like it's crimped and then soldered shut. So I'm not entirely sure because it's got external ports for filling. It could be that this is for filling somehow or another. But I'm not entirely sure. Maybe you would make all your connections, add the oil, seal it off, and then vac the system and fill it up. I'm not entirely sure. Anyway, 230 volts, 60 single phase AC, which is interesting. You would think this would be two phase because you do have two phase available at your house, but they say single phase. So it's got 3 leads coming into it because, of course, this thing weighs about 60 pounds, by the way. So I hope you appreciate the effort I'm putting in. All right, so three connectors going in because, of course, 220 is split into 2 120 volt feeds. And this one, in AC units, every one that I'm familiar with anyway, they get the extra phase to turn the motor by using a big capacitor to offset one of the phases. So one of these is going to be a phased AC input, and that's what's going on there. So there's really no way into this other than to physically cut it. So, yeah, I've been avoiding doing this one because of that. It's going to be a biatch. So, stand by. It'll be a bit. All right, put up a fight. So that's the top shell there, just in case you were curious. So yeah, that appears to be an oil line that's going in there. And this would be the outlet valve here. All right. Here's the rest of it. A little bit of acetone, mostly just to help cool it down. All right, it's not too hot. All right. Now from here on out, I have no idea what we're looking at. So this is gonna be quite the adventure. Okay, I'm gonna break off this tube here because we don't need it. All right, now I'm expecting this to be a rotary vane compressor. Now it's in here, it wobbles, and there was a spring on top as well. So I'm guessing that's for vibration dampening, to let this thing shake kind of independently of the rest. And I also noticed that there's these big rubber bumpers on the end. And probably what that's, the reason for that is probably to help isolate, oh geez, there's a bunch of oil in there too. I have to pour that out. probably to isolate it from the condenser, because the condenser is going to be very thin aluminum, and this is in that outdoor unit that you see with your air conditioner. This is the main workpiece in there. And that condenser, that aluminum condenser in there, is going to be real thin aluminum and would be subject to cracking under vibration. So that's probably just mitigation for vibration. It appears to be attached in there pretty good. All right, I think I'm just going to have to turn this thing upside down and shake it, see if I can get it to fall out of there. All right, so there's the bottom housing. You can see there's just what I assume is the return line there. There's a 3-prong sticking in, and right full of nasty, greasy compressor oil. All right, I'm gonna have to make a nice bed of paper towels here for the compressor. All right, so here is the business end of the whole thing. So that's going to be the input for the motor here. So I'm not sure which end is which. I guess we won't know until we start taking it apart. All right, so this appears to be an accumulator of some sort. Looks like it's going to require some gentle coaxing to get it off. So these are SAE fasteners. Looks like they're fine thread, 1/2 inch, or well, what is that, 3/8, so probably 3/8 by 24 or something like that. All right, so these look like check valves to me. Got 2 big beefy check valves sitting in here. So this is a piston compressor. So we can see there's 2 pistons in there, which are going to push against, try and get some of this grease or oil out of here. Oh, and I should say the reason this came out is because it was completely seized up. So that's why it came out. It would not turn. When you put power to it, it would just pop the breaker. Try and scoot this over a little bit where you can see it. Jesus, this thing's heavy. All right, so it looks like 2 pistons here that go back and forth with 2 check valves, which seat there, obviously to prevent backflow into the pump. So it can only pump in one direction. All right, on this back end, we've got a couple of E-Torx fasteners. Ugh. Back here, we'll pull those off and see. And we've got a couple of Torx fasteners, small Torx fasteners. Pull all that apart and see if we can see anything. Yellow Loctite. I've never seen that before. Oh, you know what? I think I have. I can't remember what this stuff is called, but it's for high vibration applications. If I think about it, I'll look it up and put it down in the notes section or up on the screen or something. All right, so this looks to be pressurized. There's a little bit of refrigerant in there. You can see it boiling off. All right, so underneath here, let me see if I can show you this. Oh, and let me get this out of the way. I'm fairly certain this is just an accumulator. Right here, a hydraulic accumulator in this tube, one way or another. Alrighty, so you can see down in here, we've got a little crankshaft with some connecting rods, which, yeah, you can see the 2 connecting rods there and a little bit of a crankshaft. Looks like a cast piece there. Pick this back up. So this would be kind of like the rear main bearing of the whole thing. All right, so it's just a plain bearing. You can see through-hole journals for oil. So there's going to be some sort of pump somewhere to pump oil. If that's what that is. Oh, well, that's gone forever. But yeah, so you can see this is basically like the rear main bearing housing, just a plain bearing. This appears to be aluminum, like hardened aluminum, which is not surprising. You see that in engines all the time. They surface harden it and use it as a bearing surface. Works pretty good. All right, we got a couple small torques on the sides here to take off these lines, which I'm not convinced that they're not oil lines at this point. Maybe on the other end is the actual vane part of the compressor. Yeah, I'm kind of thinking that, because there are, well, I don't want to speak too soon. No, I think that whole thing's a motor. I think so. Let's see here. All right, let me pull these off, quit shooting my mouth off, see if we can see anything else. I'm not entirely sure. Well, let's keep going and see if something becomes apparent here. So we've got these two supply lines, and these have these clips on them with a like a port. I have no idea what that's about. Maybe just like a relief, kind of like yeah, acting as like a relief valve. If too much pressure builds up, they can spill off the pressure, because it's a fairly weak spring on there. So you would think that this thing would be able to kind of cant up and let some of the pressure off if it needed to. Okay, nothing special there, just a couple of supply fittings. All right, so here's the cap. Those two lines just went in there. So I'm still fuzzy on how this works. So I have to get a little further apart before I'm willing to make any judgment calls here. All right, on this end, we've got what appears to be a thingy, a pressure switch maybe? Thermal overload switch, I bet. Yeah, so on the label it said thermally protected. That's what this guy's gonna be. I'll look up the part number on this, but I'll bet you that that's what this is a thermistor. It's a it's upside down. That's what it is. It's a 1.5 Hotel Mike 2312. Looks like a -2. And then it looks like maybe the brand name, Kilo Lima India X-Ray Oscar November, with a little restricted symbol. Then on this side, we've got a 1.5 Hotel Mike 2312-2 Foxtrot 94 Alpha 03. So yeah, I bet that that's a thermistor. Up here we got a few more torques. So these are probably, or E-torques, those are probably going to run the length of the body here. Got some through bolts that are holding the laminations, it looks like, onto the rest of the body. Oh, holy fuck. All right, so that whole piece is just the laminations for the motor. So here we have the commutator, which actually spins free. Alrighty, so that's just going to be inside here. There's probably going to be some permanent DC magnets. Let me get my little viewing film. All right, so this guy, just so I can get it out of the way, laminations. Everybody good with that? Laminations for the motor. It's just a big hunk of iron to provide the to create the magnetic fields to spin this thing. So there you go. There's a part number. Everybody happy? Good. It's out of the way. All right, magnetic viewing film. You can see it a little bit. Yeah, there we go. I don't know if you can see that or not, but there's individual lines, so the laminations are always in there at an angle. Has something to do with the efficiency of the motor. So yeah, you can see it there. There's one of them. Yeah, so there's some science to the angle that they're at and the speed that they're spinning and the who's it, what's it. So, all right, so that actually spins free. All right, so when you don't understand something, you got to just break it down into little pieces till you do understand. So we've got, coming into here, we've got what I assume is the return line. The smaller line would be the return, I think. So the return line, does that make sense? Yeah, because this is an accumulator, must be an accumulator. So it comes in the return. It goes, the check valves go the other way though, so how does that make sense? All right, so I had to sit and think about this, so it was kind of boggling my mind a little bit. Here's what I think is going on. Not guaranteeing this is correct. This is what I think. All right, so this guy is sitting in here like this, right? So this must be the outlet to the condenser, right? So everything's coming back in the top of the case. The vapor left over from the evaporator is coming into the case, and it's falling in here and slowly condensing into the bottom. Some of it's going to change phase into liquid. Some of it's not. This pump is going to somehow, I'm not entirely sure, I think that these are through holes on this pump. I think that might be the key there. So I think the coolant, the vapor coolant, is coming down through these lines that were going up to the top, right? And they're up at the top so that this can only pull vapor. Because my understanding, because if you had liquid in here, this would hydrolock. So you can't really pump a liquid. So it's pulling in the vapor from that shroud that was up top here. It's somehow or another working through, coming up through these holes as a vapor, getting compressed as it goes. So it's coming down. So the piston's coming down. It's picking up some vapor. As it comes up, that gap closes in there. I think you can see that, right? So it's varying the displacement. And I think it's forcing it up through here and fighting those check valves. And then creating pressure. You've got a little accumulator here. It comes out and goes to the, I guess it would be going to the condenser at that point, where it condenses. I think that the way the oil lubrication is working here, because this was just open, I think this whole thing's under pressure, obviously, right? The whole system is under pressure. And I think because all the liquid oil is pooled in the bottom here, it's pushing the oil up through the journals inside the pump here and just bathing this whole thing in oil. I think that's all that's happening, is the pressure pushing down is pushing it up through and causing it to kind of circulate through there. I think that's what's going on. I'm not really sure, but I think that kind of sort of makes sense to me. Or possibly this whole thing is just bathed. I mean, I guess that's a possibility as well. Now, the one thing I don't quite get is there's this little bleed valve here. You can see it goes through to the other side. It's like a calibrated leak across there. I don't know. I don't know why that's there. So that would be on the high pressure side to pressurize, to allow some of the pressure to escape into the body of the compressor. I'm not really sure why you'd want to do that. Yeah, so sorry I can't be more insightful here, but that's my best guess as to what's going on. I mean, someone out there is definitely smarter than me and knows exactly what's going on. So hopefully if I made a mistake, someone can correct me or kind of fill in the gaps for me. But my understanding is that these aren't very common anymore. I thought that the rotary vanes were considerably more common. And those are fairly easy to understand how they work. I just don't see exactly what the black magic is that's causing this to compress everything. So, yeah, anyway, unfortunately, that's all I got. So, hopefully this is interesting to someone, and thanks for watching.